Unlocking the secrets of linear transformations, targeting high school students ages 15 to 18. Have you ever wondered how computers manipulate images? Or how video game characters move so smoothly? The answer lies in a powerful mathematical tool called matrices. But what exactly are matrices? And how do they work? Let's dive in and find out. However, before we proceed, let's recap on what we did last week. So, what are matrices and how can they be used to represent and perform transformations in spaces? A matrix is a simple rectangular array of numbers, symbols, or expressions arranged in rows and columns. We describe a matrix by its dimensions, that is, rows by columns. For example, a matrix with 2 rows and 3 columns is a 2 times 3 matrix. Just a note, each number in the matrix, that is actually called an element. You're seeing some examples on the screen. Now that is the 2 times 2 matrix and also the 2 times 3. Now, just for knowledge, let's dwell on the addition and the subtraction of matrices. Now, matrices can be added and also multiplied by scalars, right? To add matrices, they must have the same dimensions or dimensions. We add the corresponding elements. Remember that the elements, they're actually a number within the matrix. So each number in the matrix is called an element. Wonderful. So as I was saying, the scalar multiplication, it involves the multiplying of each element of the matrix by a single number, which is called the scalar. You're now going to see a representation of the subtraction via matrix. Kindly watch. Make some So matrix multiplication is a bit more complex. It is used to represent linear transformations like rotations, scaling, and also reflections. Now, the number of columns in the first matrix must match the number of rows in the second matrix. The resulting matrix has the number of rows of the first matrix and the number of columns of the second matrix. You are going to see an animation. It is basically a demonstration of the matrix multiplication. Now this shows how rows of the first matrix is multiplied with the columns of the second matrix. Please watch. I love how this class is. They're so engaging. So let's continue. So there are various types of matrices. In this presentation, we're just going to name a few, maybe just four, for a brief. So let's proceed. So 1, you have a square matrix, you have rectangular matrix, you have identity matrix, and you also have zero matrix. Now for the square matrix, it is a matrix with the same number of rows and the same number of columns. Example, 2 times 2 and 3 times 3. So that would be 2 rows, 2 columns, or 3 rows, 3 columns. Now you have the rectangular matrix. Now this is a matrix with different numbers of rows and columns. Example, 2 rows, 3 columns, 4 rows, 5 columns. Wonderful. Now we have the identity matrix. Now this is a square matrix with ones on the main diagonal and zeros elsewhere. So it is ones on the main diagonal and zeros elsewhere. Wonderful. Lastly, we have the zero matrix. Now this matrix, all the elements equal to 0. Remember that an element is the number of matrix, right? That's correct. So a matrix, a zero matrix, is one where all the elements equal to 0. So last but not least, let us focus on some important points of matrices. So matrices are used in many fields, from computer graphics to solving complex equations. They are a fundamental tool in linear algebra and have countless applications in science and engineering. Now matrices, they play a crucial role in 2D graphics or 2D drawings, right? Enabling various transformations such as translation, rotation, scaling, and reflection. Now translation matrices, they move objects from one position to another, while rotation matrices rotates objects around the pivot point. Now scaling matrix or matrices, on the other hand, they basically resize objects, maintaining their aspect ratio, and reflection matrices, they flip the objects over horizontally or vertically on the axis. Now,
as a teacher, I've seen how it has helped students visualize and understand complex mathematical concepts. The interactive tools and real-time feedback have made learning fun and engaging. Matrices has revolutionized the way we approach mathematical problem solving, and its applications are evident in various real-time situations. For instance, matrices are used in computer graphics to create 3D models and simulate real-world environments, such as in video games and special effects in movies. Additionally, matrices play a crucial role in data analysis, as seen in Google's PageRank algorithm, which uses matrices to rank web pages based on their importance. Furthermore, matrices are used in medical imaging, such as MRI and CT scans, to reconstruct images of the body. Even in social media, matrices are used to recommend friends and content based on user behavior. These examples demonstrate how matrices are used to solve complex problems and make a significant impact in